So you click on technology assignments. This actually is probably the easiest one out of all of them, but it does involve a little bit of writing, but that writing could involve a fair amount of copy pasting. All right. So do midnight on the date of the third unit test, which at this moment, I honestly can't remember the date of. I think it's in a couple of weeks, but I'll double check on that. All right. But for now, we're just getting started on this anyway, so it's fine. Believe it or not, we're kind of closing in on the final few topics of the course, which is surprising and also gratifying because we're almost there, you know. And this is the last technology assignment. So the sooner you get this done, the sooner you're done with technology assignments. All right. So that's exciting. You know, we're starting to finish things off now, which is good news. So you know, this blurb is the same blurb as it's been all semester. 20 points available. You know that technology assignments are a significant part of your average, so you don't want to go to sleep on this. You want to make sure you get it done. All that stuff we've talked about already. Access the tech assignment. It's tech assignment C, quadratics using quadratics. Geez, that's fun. Quadrics. It's not a typo. It's actually pronounced the word is quadrics. It's not quadratic. But it is really an extension of quadratics just into the third dimension. And so in a sense, it kind of is quadratic. But you'll see here that there isn't a whole heck of a lot to do. Everything is kind of described for you. All you're really going to do is determine what each of the sliders for each of the different quadric surfaces controls, right? And it's as simple as that. So you look at this and you see, okay, the first one is a sphere. And you see the general model is x minus x sub o squared plus y minus y sub o squared plus z minus z sub o squared is equal to r squared. I find the subscripts to be kind of a pain, so I try to avoid them wherever possible. So I used A, B, C, and D instead of x sub o, y sub o, z sub o, and r. So just a little thought. You know, it's not something that everybody likes to do, but it's something that it's easily done. So let me just open one quickly. Geogebra.org/3D. And really, the only reason why I've ever asked anybody to do this tech assignment, aside from a nice easy grade, is because in the past, when I've asked people to explore quadric surfaces on their own, they just didn't. They're like, yeah, I'll do that at some point. And then that some point never happened. And so it's just kind of like me mandating that you actually get to know these things, because it does make life a lot easier. I'm just turning on the labels here. All right, so we have the sphere equation again, x minus x sub o, y minus y sub o, z minus z sub o, and r. Right, so I'm going to do x minus a squared plus y minus b squared plus z minus c squared equals d squared instead of r squared. As long as it follows the same model, you're okay. When you hit enter, it creates all the sliders for you, unlike Desmos where it asks you if you want to create sliders. Here, it just flat out assumes that you want to. All right, calls it equation 1, plotted a sphere, looks beautiful, floating in space. And so all you're going to do is tell me what the A controls. It appears to control movement along the x-axis. The B appears to control movement along the y-axis, and C along the z-axis, and D appears to be the radius. All right. So very simple, not really asking you to make any kind of earth-shattering observations. All right. But what I just said about A, B, and C, I don't want you to just leave it at that. That's too simplistic. If you were to say A is the movement along the x-axis, that's great. That's wonderful. I think if I asked my freshmen in high school to analyze this, that's probably what they would come up with. I want more out of you. So if you look at the center, so if I plot the point A, B, C, all right, so here's point A, B, C. And now compare that with the A, B, and C's up here. You see that they're the same because they're reliant on that. Now, if I move, you know, just keep the B and the C values wherever they are, but just move the A. If I move that A value out to a 1, as opposed to a -5, where is it going to end up? A good idea here is to get it as a top-down view. Right, sorry, hold on. Let me go. I didn't want to do that. I'm going to go home. A top-down view so that X and Y are in their ordinary positions. Right, so just thinking back to like anything that's two-dimensional. So if you look at where this graph is now, you can see that the center of the sphere, or maybe you can't, let me just move it in. I'll move it up a little bit. You see that the center of the sphere has an X value of -5 and a Y value of -2, right? So that A value, or in the case of the notation in the original tech assignment, that A value represents the displacement of the X component of the center, right? The B value represents the displacement of the Y component of the center, and the C value, I mean, you look at it from this perspective, it doesn't look like it's doing anything, but that's because the sphere is moving closer to you and further away from you and not changing in size, right? So we're talking about horizontal and vertical translations if it were in an XY plane, but really it's just a translation, right? So use the proper terminology. Don't just say it moves left when I make it smaller, it moves right when I make it larger. That you're not going to get full credit for answers like that, right? So I'm looking for a little bit more, right? So just do your best, and I'm sure it'll play out the way you want it to, right? So that was the sphere, and you can see for the ellipse, it's really the same idea, except you're going to have more values on the bottom. And you see what I did here. I just created subscripts, just more sliders, more function models. You're doing the same thing with hyperboloids. You have two types of hyperboloids, the elliptic hyperboloid of 1 sheet and the elliptic hyperboloid of 2 sheets. And then you have paraboloids, the elliptic paraboloids and the hyperbolic paraboloids. So you have a total of 1, 2, 3, 4, 5, 6 different graphs that you're creating. If you're savvy enough, you'll get them all onto one GeoGebra. If not, you can send separate ones. But it's the write-up that I'm more interested in, right? Because it's very easy to come up with these graphs. It's the analysis that I'm more interested in, and I'm looking for really anything other than the simplistic, right? So let me stop that share. So you can get started on that right away. Again, it's due the day of the next unit test. Also, I'm going to be posting the bonus unit circle quiz. So I'll post that up either tonight or tomorrow. I don't think I've already posted it. So so be on the lookout for that. Right, just like the last two, it's worth 3 bonus points. So if you get it in under the whatever I decided the stated time, it's usually the 2-minute mark, or 2 or 3 minute mark. This one's a little harder, so I might make it a little longer. I got to think about it. But if you get it in under the required time, while also being 100% perfect, then you get 3 bonus points. Right. So I'm going to stop the recording.